All right, record and resume. All right, so you guys had this lab page. Hey, does this lab page look like a lot like yesterday, those Kirchhoff tables that we were doing? Right, so what do we got here? We got different locations, different resistors you can have on a circuit. We got the voltage source. What is the resistance? What is the potential difference of the voltage? What is the current in amps? What is the power in watts? Okay. So I'm going to have you guys do 3 different circuits today. 1, 2, 3. Right. Now I'm going to give you guys a very simple example. You guys want to see a very simple example with just like one resistor? Okay. So draw in this blank space out here, draw a schematic of what you're doing. So I'm just going to do, again, very simply, just a circuit, a closed circuit that just has one resistor on it. Okay. And that would be the schematic, right? Okay. I've got for you guys cell phone chargers for which is going to give you guys 5 volts. So if you plug your charger into the outlet, again, you don't want to go jamming the leads of your multimeter directly in here. No, because that's how it creates fireballs of fun. I should say of destruction. Don't do it. It's a bad thing. And you frame that in a bad way. But now we're down to 5 volts DC. 5 volts DC, right? Okay. Now I'm going to put the breadboard aside. So for this lab, really just use the Christmas lights. Again, if you want to get your hands on the breadboard, go for it. But really, you just do this whole thing with Christmas lights. Okay. So what we got here? Oh, look at that, lights up. Okay. Now I wonder. Now for one, since I only have one resistor, I'm not going to care about these 2 guys, right? This is just a single resistor circuit. Okay. I wonder what the resistance of one of these bulbs is. You know what? Actually, I can figure out sort of backward, like if I know the voltage across one of these and I know the current through one of these, I can use Ohm's law and figure that out. Okay. So what is the voltage? Okay. So this multimeter, right? Guys, tell you guys how this works, and I'll be back in the lab area to help you guys out. Right. This multimeter can measure voltage drop, it can measure current, but you have to know what you're doing. So you guys see this toggle switch? Anything to the top left here are volts in DC, like DC volts, which is exactly what we got working on. Right? So I'll just pick one of these. It just moves the decimal. See how it moves the decimal around? Okay. Now it should be about 5 volts because the cell phone charger is 5 volts. So I mean that should pick up 5 volts right there, right? Okay. Right. Also, there are 3 places to plug into this voltmeter. Always put the black one in COM. See where it says COM, COM. Right. So just as a rule, just leave that there. Don't touch it. But the red one, see, you can move around depending on what you're trying to measure. Now, one of these says volts, ohms, and also temperature. This is what you can gauge temperature on this. So put that one. The one says volts because I'm going to measure what's the voltage. Okay. That's what it does. Right. Now, using this multimeter, since it has different functions in it, you measure voltage and current differently. And I've got a schematic on the back to remind you guys how to do this. Voltage, remember, you're measuring potential difference. You actually put this in parallel. See how the current actually goes through the resistor, and I'm measuring what's the voltage here, what's the voltage here. Kind of like measuring the height of a waterfall, right? You want 2 different elevations, right? Versus later on, which we're not at this part yet, when you measure current, see how I broke open the circuit and forced the current to flow through the multimeter, through the ammeter, right? Right. So that's a different setup, right? So hold on to that thought. We're not quite there yet, but I'm just going to start with voltage. Okay. So voltage. I got my leads, got this, okay, lit up, all good. Okay. Now, I'm going to put attach the red to the red. I know my finger's kind of in the way, but guys use your imagination here. Okay. Attach the black to the black. Okay. And okay, when it was lit up. Okay, get in frame here. You guys see it says 4.8 volts, 4.8 volts. Hey, that's really close to 5 volts, isn't it? I mean, the advertised voltage on those cell phone charger is 5 volts. This is saying 4.8. Right, I'll go with that. That looks about right. So over here and potential difference, I'm going to put 4.8 volts. Okay. Now keep in mind, if you have a string of resistors, think about what 2 points you're measuring the potential difference. Because you might be measuring the potential difference. If you go from lead to lead across the cell phone charger, you should always get something pretty close to 5 volts. But across an individual resistor, say if you have a few resistors in series, it might jump down a little bit. Think back to yesterday, right? In fact, you might want to use your Kirchhoff models from yesterday. Help you out. Now, current and amps. I told you guys this, you're going to have to make some switches. Okay? I'm going to show you guys your switches. I'm going to switch this toggle over to there's one that says MA, like milliamps, that I think works pretty good. Anything with the solid line over, like the solid line, the dashed line refers to direct current. Those wavy looking lines refer to alternating current, which we are not doing, right? So we're just doing direct current, right? Okay. So you guys see a switch to toggle switch. Another thing I need to switch on this ammeter, for multimeter. Now I need to turn this into an ammeter. The way we did is take this red plug-in, pop this out, move it over to the one that says amps. You guys see it says amps right there? Okay. Plug that in there. Okay. Now this thing is ready to read current. Okay. You guys saw it. I switched this from here to here. Right. Right. There's another change I need to make. I need to break open the circuit, just like that diagram I showed you on the back of this paper. See how this is an open circuit and the light bulb isn't even lighting? Right. Touch the red to the red side, the black to the black. Right. And now it's lit up, but see how the current is forced to flow through the multimeter? That's different than the voltage, but the current needed to do that. I wonder how many amps of current this is. Let's see. I'm seeing 2.3 amps. You guys seeing 2.3 amps? Okay, 2.3. Right, so I go over here to current in amps and write 2.3. Okay. Hey, do you think we can figure out the whole thing just from those two numbers? Okay. Let me turn off my multimeter, switch back to volts, get ready for the next circuit. Okay. Maybe I'll unplug this just for safety. So I got one more pop sound. Ohm's law, V equals IR. You guys remember that? Right, or I equals V over R. So V equals IR. So if I take my volts, 4.8 volts, and I divide by the current in amps, divide by 2.3, shouldn't that give me the resistance in ohms? Right? I've got Ohm's law up on one of these posters up here. Right? V equals IR. So you can switch around. I'm getting about 2.1 ohms. 2.1 ohms for a single Christmas light. Now, all your Christmas lights, I mean, they're all manufactured about the same. So as a rule of thumb, these guys should be approximately 2 ohms each, right? That kind of makes sense, right? And last one, power. I show you guys 3 formulas for power, yes, in the last few days. One of them is just I times V, right? So let's do 4.8 volts times 2.3 amps. And the power is 11 watts, 11.0 watts. Guess that, right? Okay, so a bright bulb, probably about 10, 12 watts, somewhere there. Right. Okay, so rest of class today, you guys got the rest of class to, here's your goal. Come up with 3 different circuits, fill out the tables for those circuits. If you want to play around with the breadboards, got them off to the side. If you have any questions, let me know. I'll be around to help you guys out. Right, when you guys finish, pop this in the grade tray at the end of class.